So, hi everyone, my name is Joshua Oliver. I'm a recent computer science graduate from Washington State, as well as an ex-AgAid intern. And my project this summer was on the integration of evapotranspiration, or ET data, into the AgWeatherNet Smart Farm. A little bit of background, evapotranspiration data is a numeric value that represents the combination of water that's both evaporating through your soil as well as water that's transpiring through your crops. So in simple terms, it's a direct estimate of how much water is leaving your field. As you might imagine, this is a very vital numeric value for any irrigation management or decision making that has to be made. It is the backbone of irrigation prediction and estimation, as well as serves various utility in crop modeling. One of the important companies today when it comes to ET estimates is called OpenET. The reason they're important is because traditional ET estimates can often take a fair amount of effort to produce. It's not always the easiest calculation to derive, and OpenET provides a kind of a stop and go interactive platform for a user to view ET values across almost any field in the Western United States. They do this by utilizing satellite imagery as well as energy balance models to deliver 30-meter resolution ET data. Another important aspect about this company is that they are a open source, well-documented company. They're backed by NASA, USGS, USDA, and other top universities, making them very well trusted and respected. Additionally, a key component of this website is its ensemble model. The ensemble model is essentially an average from the other 6 energy balance models. So what that does is help reduce any bias that one of those 6 energy balance models might produce by so the ensemble model will allow a more accurate representation of the ET value for that field. How this comes into play with the AgWeatherNet Smart Farm is that the Smart Farm provides an interactive platform for grower-installed sensors. So a grower can go and install soil, weather, crop sensors into their field and use the Smart Farm platform to view and interact with that data. By adding OpenET data to it, it just provides the grower with that much more information about their field to allow them to make better decision making and allow them to further automate their fields and farms as a whole. The Smart Farm webpage is hosted on the AgWeatherNet website, which is a public website for Washington State that focuses on target forecasts, models, and climatology. It provides various tools and models for crop decision making and understanding, such as shown on the left is an example of one of the models, the pollen tube growth model used for apples. And on the right-hand side is the AgWeatherNet homepage dashboard, which showcases all of the public weather stations in Washington State for public weather data display. How we were able to integrate the Smart Farm webpage as well as OpenET data into AgWeatherNet was by first using the React JavaScript framework for real-time responsive UI front-end handling. And we also utilize the Golang backend language for optimized, fast, responsive API route handling and overall system logic. We did have to go through Google Earth Engine in order to actually pull the data from OpenET. But once we had that configured and set up, we were able to process that data and store it into our AgWeatherNet database for later display on our web page. This database was through MariaDB and was hosted on Amazon Web Services. There is also a cron job that was scheduled to synchronize that database with daily values, so everything stays fresh and dynamic, and we don't have to do it manually. A cron job is essentially a script that's scheduled to run at a specific interval, so it's an automated process. In terms of the actual product, what this is showcasing right now is the Smart Orchard in Prosser, Washington. As you can see, I've selected one of the sensors installed in that field, and it renders with a drop-down of all the variables that sensor is currently recording. So you can go through and toggle on the different values, and it also will update other similar sensors with their corresponding value across all your fields. So as I'm selecting soil temperature, it's updating the value in the marker. And once you can also select different sensors, which will render different components that that sensor is recording. So for example, these variables that are being rendered from this top sensor are different from the one that is different from the ones that are currently being rendered from this middle sensor. For example, this middle one contains the OpenET component where you can toggle between the different energy balance models and it will update the value in the marker as well as on the gauge. And this works for any one of the 7 energy balance models that they have. The second half of this web page is the historical data aspect or chart data. So for any one of these variables, you're able to view the raw data stream that's coming in from the sensor and view data for any range of a given time, the last 24 hours, the past 7 days. You can specify your own custom range of days and times you want to see data for. And as long as there's data available in that window, it will display. So this is what it looks like for the OpenET component. I've selected the ensemble model in a 7-day range. So it's showing the ET values given by the ensemble model for the given field across the past 7 days. You can also toggle on and off the different values at the bottom of the chart there. So if I wanted to compare one model against another or see what all the models are recording, you can do that as well. There's also the inclusion of ETO and ETR values for additional information as well. And choosing an option from the dropdown does render the chart with that selection. So overall, what OpenET is doing is very important, but it's not perfect due to their reliance on satellite imagery. There is often a 5 to 6 day gap where data is not currently available for that given field. So they will rely on the last recorded value for that field until the next satellite pass happens and they can update the past 5 or 6 missing days of data. Additionally, there's consistent refinement on the energy balance models they use, which means we have to stay updated with the changes they're doing as well. But in terms of what's next for this project, we want to continue ET integration for more fields for the AgWeatherNet Smart Farm, as well as provide different variables that OpenET also produces, such as the normalized difference vegetative index values or NDVI for a given field, as it is very useful for growers and farmers to understand and see that data as well. Finally, there's a few bugs that remain that we need to fix, but overall, I've learned a ton about modern web frameworks and practices, as well as just how difficult ET can be in this industry. In terms of calculation and measurement, I really had no idea until this project, so that was pretty eye-opening. And finally, I could not have done this without the help of a team, so thank you to everyone who was involved with this project. I've learned a lot and had a great time returning once again for another summer. So thank you.